Today we're looking at MITRE attack number T1573, encrypted C2 channel. In this case, we're going to use a very simple OpenSSL C2 channel to emulate an attack. So let's jump over to Atomic Red Team under technique T1573. I have that open here. It's a PowerShell command. It says make a new socket or a new network connection to the server and IP we specify, and then this starts the whole C2 communication here, and that's it for the script. Super simple, and we can specify where we want it to connect to, the server IP and the port. In the description it says thanks to OR1 equals 1. That's me. You might think I'm vain, and maybe it's true, but I didn't make this atomic myself. I talked my husband into doing it, and so I only get partial credit for being vain. So we have a link here to my blog post over on Walmart Labs Medium. Let's take a peek at that, because we need to set up our own C2 server to connect to if we want to make this super realistic. So instead of connecting to localhost 443, we want to connect out to an actual C2 server on the internet to prove this out. So on this blog post, it shows the code here that we saw in the atomic, but it also gives us what we need to run from our C2 server. So C2 stands for command and control. So in that case, we have one computer that is a server or a controller of like another computer, which is the victim, and it's the client. It calls the server and says, hey, C2 server, is there any command you want me to run? The server will say no until it's ready to run something. Then it'll say, yes, actually run this command. The client or the victim will run that and return the results to the server where the attacker would be sitting. So in this case, we need to create an OpenSSL certificate. So OpenSSL comes installed on Linux by default, and I've deployed an Ubuntu Linux server out in the DigitalOcean cloud for us to use today in this demonstration. So we just do this to create a digital certificate and a key, and then we just use this OpenSSL command to start our listener. So the thing that our victim is going to call out to find out what commands it should run and return its results. So let's get that part set up. We're going to SSH to our C2 server on DigitalOcean. Okay, we're connected, and we're going to run this first command. To create our certificate. Move that over so we can see it. So this is obviously just a self-signed certificate. We can make this attack emulation more realistic if we use the free Let's Encrypt service to give us a legitimate certificate. We could even specify a domain name to use, since that's more believable than a raw IP address. But for simplicity today, we're using a self-signed certificate. And we're going to just accept all the defaults because we don't really care for our testing today. Okay, so now we have, if we list out the contents, we have a cert.pem and a key.pem. Those are needed to set up that C2 listener. Then we just need to run the second command to start the listener. In this case, we're doing that on port 987. That'll work for today, but if you're working on doing a more realistic emulation, you'd probably want to use something that's highly likely to be open out of any network, which is port 443, for example, or port 80, the HTTP and HTTPS ports, or port 22 would be another good option. So here we go with port 987. Okay, so that's just going to sit here listening for a connection. So let's put this over here, and we'll start up PowerShell on the other side. We're going to say invoke atomic test T1573, and we'll say show details brief. And there's only one test under technique T1573 in the Atomic Red Team library of scripted cyber attacks. So we don't need to specify a test number. We'll just say run all the tests, which is just this one test. Well, before we do that, let's show the details, which is just going to be the same thing we saw in the markdown file on the web. So we have this PowerShell script here. We've got some arguments that are going to be replaced. Server IP and port. The default values for these are localhost and port 443. We want to use our actual DigitalOcean IP, and in our example we're using port 9876. So we need to ask this invoke atomic red team execution framework to prompt us for the input arguments. So we'll say dash prompt for input arguments, and it's going to say what port do you want to use. We can push enter to accept the default port of 443, but we're going to use 9876. And what IP address. We don't want to connect to localhost. We've set up our own server, and that server IP of DigitalOcean is here. I'll copy that, put it in here, and we'll give that a try. And we get a warning that says this script contains malicious content and has been blocked by your antivirus software. So here we have a default Windows install. We have Windows Defender active and updated, and it has blocked this script. Let's take a closer look at what exactly Windows Defender doesn't like, or what it's considering malicious. We've learned from our other atomic spotlights that just because Windows Defender snags it doesn't mean we should give up. There might be some possibilities we have for still making this work. So in order to play with this in the easiest way, I'm going to bring up the PowerShell ISE, the integrated scripting environment, as an easy place to play with stuff. I'm going to take the code from this test. Let's go ahead and print it out here. So we're going to take these commands and put it here in the Windows PowerShell ISE. And we were using a different IP, so let's grab that. And let's just put it right into this command here. And we'll go port 9876. And we're not using these variables on line 1 and 2, so we can delete those. Let's go ahead and run this to see if Windows Defender is still not liking this script. So we run this, and it still says it's been blocked by our antivirus software. So this is where we start experimenting. It's complaining about line 1. So let's go up and play with line 1. For starters, I'm wondering if Defender just doesn't like us using TCP client. So I'm just going to erase a letter from TCP client. I know it wouldn't actually work as a script, but we're just prodding Windows Defender right now. So we try this, and it still says it's been blocked. So then I think, well, maybe it just doesn't like the word sockets anywhere, because a socket sounds like something bad, maybe. So we'll try that. And it still says it's been blocked by antivirus software. Let's keep going. Maybe it doesn't like using a raw IP address. So we could do some.domain.com and run that. Still blocked by antivirus. Well, we don't have a lot of things left to play with. It could be port 9876. We could try that. Maybe it's this new object thing. So we erase that and push F5. We get a lot of errors. Of course, it's not going to work, but it looks like something different happened. If we scroll up, we don't see anything about Windows Defender blocking. It just doesn't like this command because it obviously isn't going to work. So through that testing, it looks like Windows Defender doesn't like seeing new object on the first line, at least. Let's go back, put everything back the way it was, Control Z. Okay. So in PowerShell, we can make aliases for other commands. So we can make an alias, like instead of saying new object, we could say, let's make an alias that says whenever I type in NO, it means call new object. So we could do that with the set alias command, set alias, and we could say NO, whatever we want for an alias that isn't new dash object, because Defender is not liking that. And tell it when I type NO, I want you to actually call new object. And then we just replace new object with our alias NO, and we give that a try. Let's bring up our listener over here to see if anything's going to happen. And let's go. Hey, look at that. We have a PSC users ARC. So now we have a PowerShell prompt from our victim machine here. So right here we're SSH into a DigitalOcean C2 server where we ran two commands. One to use OpenSSL to create a certificate and a key, and two to that one-liner to start a listener on port 9876, which you have here. So we could prove that this is working. Well, first of all, Windows Defender didn't snatch it up and it successfully made the connection. So it looks like that's all it took to get this going again and to complete this emulation. Let's go over and show our desktop here. Okay, so we're looking at our desktop. Let's see if we can use this console. So we're the attacker here, out here on our DigitalOcean instance. We see this shell come in, or this connection to our victim server, and maybe we would, well, we could do any command, but just as a proof of concept, we'll add a file to the desktop. So add content, and we'll say to the desktop c2.txt, and in there we'll say gotcha. And we see that pop up on our victim machine. We open that up and it says gotcha. So this proves out that we were able to successfully emulate that C2 traffic using an OpenSSL C2 channel, which is an excellent option for pen tests and red teaming, where you're just trying to prove out that C2 communications can be established. This, as written, is not a powerful C2 communication channel because only one client can connect at a time, and it's very fragile. There's lots of things you can accidentally type wrong to make this client connection not function anymore, and then you'd have to re-execute your payload on your victim machine to get the client to reconnect. But definitely good for proof of concept. Isn't that cool that we were able to use OpenSSL library built into Linux operating system to start up a server, C2 server in the cloud, and listen for connections, and then to use this little bit of PowerShell with a little bit of engineering to allow Windows Defender to let us run this, and then we get our C2 connection. Definitely something we can emulate in our environments and work to detect and block. That's it for the Atomic Spotlight today. If you would like to learn more about all things attack emulation, check out my Attack Emulation Tools course on Antisyphon Training.